right, boys and girls, welcome back to the drive-thru. Special shout-out to Moldy Pie, our mascot. Okay, these get harder as we go, okay? Look, here's what I want you to know. The square root of 75 divided by the square root of 3 is the same thing as the square root of 75 divided by 3, okay? Which is the same thing as what, class? What's 75 divided by 3? 25, which is the same thing as 5. Good. So far, so good? If they were only all that easy. Okay? But hey, we're going to use that same logic. So the square root of 63xy cubed over 7y is the same thing as that. I could just write them. And again, eventually, you guys aren't going to have to write all these steps out. I just want you to understand what you're doing. Okay? So now we can start canceling. What's 63 divided by 7? 9. And y squared divided by y? Sorry, y cubed divided by y? So this is going to be a squared, and that's gone. So we get 9xy squared. Okay? So you got 3 things in there. Alex, did I mess something up?
No, but I was just confused about how I got 3 to 2 by dividing, subtracting them.
Oh, I meant to start out with that. Good question. So when you have y cubed over y squared, or y cubed over y cubed is y times y times y, and y divided by y is 1, and that leaves you with y squared remaining. So you subtract the exponent, but what you're essentially doing is canceling. Does that make sense? So y to the 5th over y squared, what does that equal? Y cubed. Yeah, y to the 3rd. Okay? Excellent. Good question. All right. Nope. Back to this one. Okay, so we're still on this one. Square root of 9 is 3. Square root of y squared is y. So our answer is 3y. And whatever you can't cancel, you just leave in there. Okay? Holly, I'm going to wait till you give me a confident face till I move on. There you go. Okay? All right. So I'm going to rewrite that. I'll skip the first step this time. See if we can. Well, I don't want to do that because I can't even read it right. That's 54. What does that say? X to the 5th. And then what's y to the 3rd? Over 2x squared y. Okay. All right, so we'll just rewrite that and simplify it. It's the square root of 54 divided by 2 is x to the 5th divided by x squared. X cubed. Everybody understand that and agree? Y cubed over y. Y squared, okay. All right, before I take out that y squared, now I've got to kind of go back and re-practice what we did yesterday. And so 27 is not on that list of perfect squares, but 9 is. So let's rewrite that as 9 times 3. And let's write x cubed as x squared times x. And then we'll just rewrite our y squared. And now I'm going to take out the 9 and put a 3 here, because the square root of 9 is 3. I'm going to take out the x squared and put an x here. I'm going to take out the y squared and put a y here. And all we have left on the inside is 3x, right? So it's 3xy times radical 3x. Okay? So far, so good? All right. So, once again, it's the directions that will throw us off. Rationalize the denominator. Okay, all that means is take any radical signs away from the bottom. The denominator is the bottom. There's a trick to this, okay? So I'll help you. I'm going to rewrite it because I can't see it that well. All right, what's the only number we can multiply by in math that doesn't change the value of our thing that we're multiplying by? 1. So that's our strategy. Multiply by 1. You do that a lot in math. Okay? It's weird. You do it with fractions a lot. So you always are going to multiply this by whatever the denominator is over itself. So all we've done there is multiply by 1. We're allowed to do that. So what we're doing is we're making this thing look different. Why are we taking the time to make it look different? Good question. I don't like doing that. But it's because the directions told us to rationalize, and rationalize means take away the square root from the bottom. So what do we have on the top? We have a square root of 5y. Okay? And what do we have on the bottom? Well, what's the square root of 5 times the square root of 5? Square root of 25, and what's the square root of 25? And that's your answer. So all we did was rewrite that so that there was no radical in the denominator. Okay? All right, so now in 35, we combine what we did on the last page with what we did in number 34. So take it as far as you can. So let me start by rewriting it. Square root of 18 x squared y over the square root of 2y, does that say cubed? Okay, what's 18 divided by 2? So we'll do this. We have a 9. Okay, the x stays on top, x squared stays on top for now. Okay, and now what we have is the y on top is gone. And what happens to the y cubed on the bottom? It changes to y squared. Okay? All right, we got this. What's the square root of 9? What's the square root of x squared? And what's the square root of y squared? All right. Why did I make which one a fraction? It already was a fraction. I just went from 2 radical signs to 1 big radical sign. Okay? Just like we did on the last page. So one thing that, if you look at this worksheet, they're constantly messing with you. Sometimes, I'm just making this up, so you don't have to look at your worksheet right now. Sometimes they write it as radical x over radical y. And sometimes they write it as radical x over y. And it's important to me that you guys understand that's the same thing. Okay? Just like practice. What if x was 25 and y was 16? Well, this one you would get, what? 5/4. And this one you'd get the square root of 25/16, which is still 5/4. They're both the same thing, is all I'm telling you. Okay? All right, number 36. This is going to be more difficult because it's cube root. Cube root of 7x y squared over cube root of 4 x squared. Wow. Okay. So, we got some cancellation going on. We are going to take away that x and make that just an x on the bottom. So we end up getting the cube root of 7y squared over 4x. Actually, I should separate those. It doesn't matter, but it's easier for me to explain it to you this way. Over the cube root of 4x. Alex, you got a question? Okay. All right. Look, I can't even promise that I'm going to put these on the test, but this gets a little tricky, okay? Whoops. Whoops. Give me a second. I told you I screwed this up earlier. All right, now look, when you get rid of a square root, you multiply by a square root over a square root. We've done that before today. We did that over here. Remember that? Okay, when you get rid of a cube root, you got to multiply by that thing twice because it's cubed now. So what you got to do is multiply by the cube root of 4x times the cube root of 4x over the cube root of 4x times the cube root of 4x. This is the strategy when they're cube roots. You won't have to do this a whole lot. This is difficult, okay? So just multiply everything out. On the top, what is 7 times 4 times 4? Somebody help me out with that. 112. You get the cube root of 112. Sorry, this should be, yep, this is right. 112 y squared x squared. And on the bottom, you get just 4x. Because you end up getting the cube root of 4x cubed. Okay? That was the whole strategy. It's tough. Don't worry about it. Okay? And we're done. Because none of these are cubes. Okay? Well, hold on. Let's see. What's 3 cubed? 27? What's 112 divided by 27? Okay. What's 112 divided by 6? No, what's 112 divided by 8? That's what it is. Okay, so we're not done. I lied. Okay, so look. I'll rewrite the next step. Just do your best. Don't worry about this. You might not ever need to do this again. So, we're going to rewrite the top as 8. The cube root of 8 times 14 times y squared times x squared. That's fine. Giving up's an option. Okay? What's the cube root of 8? It is 2. So that's 2 times the square root of 14 y squared x squared over 4x. And we did all that so we could just cancel that 2 and make that a 2. And you end up getting cube root. These are always cube roots. 14 y squared x squared all over 2x. And I would have to guess, at best, that's a bonus. So don't sweat it, okay? All right, so from something that I don't care about too much to something that I do care about, and that's these word problems, okay? I told you in our little individual meetings that I'm going to try to help you with geometry as much as I can. So here's an example of a geometry and algebra 2 question mixed up in one. Okay? The area of a rectangle is 30. If the length is square root of 75, what is the width? It doesn't matter what you call the length or the width, because that rectangle can be rolling along however you want. But you know that to find area, you do length times width, or base times height. So 30. You don't square the 30 because you see a square there. This stands for square meters, which is how we measure area. Keep in mind that, like, a guy that cuts grass for a living, he's not going to charge the same amount for every yard. If a yard is bigger, he's going to charge you more. So how does he do that? He measures the area of your yard and charges you that way. Okay, that's why we need area. So 30 is radical 75 times W. What's being done to the W? It's being multiplied. How do you get rid of multiplication? Divide. And so now you see why this question is in today's lesson. Now we have to simplify this. So W equals 30 over radical 75. Let's go ahead and start by just multiplying both sides by radical 75 over radical 75. So it's 30 radical 75 over 75. If you wrote your answer like that, I'd be totally fine with it. But I'm going to keep simplifying because that's kind of the point of today's lesson. Okay? I'm just changing that 75 to 25 times 3. What's the square root of 25? 5. And 5 times 30 is 150. So you get 150 radical 3 over 75. And 150 divided by 75 is 2. And this answer is 2 radical 3. Okay? All right, so this lesson is on dividing radicals, and this particular process of taking the radical out of the denominator is called rationalizing the denominator. Here's where it might show up on a ACT, okay? All right, throwback question. Okay? You might see this on your SAT. Find, I don't know. Let's see. Tangent of 30. And you might be good at SOHCAHTOA. If not, we're going to start reviewing this, okay? Tangent, SOHCAHTOA. What's tangent? It's opposite over adjacent. And so it would be? But on your SAT or ACT, you might have these as your options. I think there are E options, but just bear with me. You might have 1/2. You might have 2. You might have radical 3 over 3. And you might have parts. You know, some dumb answer that you wouldn't pick. Okay? So, which one is it? It is C. Very good, Brenna. You see what they did? They rationalized the denominator. They multiplied by radical 3 over radical 3. And what's 1 times radical 3? And what's radical 3 times radical 3? Radical 9, and radical 9 is? Okay? That's why that's important for the short term. Boom?